Okay, I'm going to do one more example of proving a specific type of quadrilateral. Now remember, if you want to do stuff with the sides, because those are the properties that you know best, then by all means go ahead and do that. So, proving a type of quadrilateral. Again, I'm going to make like a little table over here: parallelogram, rectangle, rhombus, square, so that I can roll things in and roll them out. So this is example 2, and I have some figure, and I have that A has the coordinates of -8, -4. B has the coordinates of -5, -4. C has the coordinates of -5 and -1. And D has the coordinates of -8, -1. Okay? So, if we look at this, I have diagonals AC and BD. I do like to start in the same spot, and that's dealing with the diagonals. So, what do I know? I'm going to ask myself the same question. Are diagonals congruent? Now, I just like to start there all the time. Because if they're congruent, I know that it's either a rectangle or a square. Or if they're not congruent, then that rules those items out. So, AC, square root of. Again, you might want to pause this here and make sure that our work actually matches. If I clean this up, I get -13 squared plus positive gives me -3 squared. I get 169 plus 9 gives me the square root of AC equals the square root of 178. Okay, that's one diagonal. Let's do BD. So BD is going to be -8 minus a -1. So, losing my marbles, -8 minus a -5. What the heck? Minus -5 plus -1. Gosh dang it. Minus a -4. Until it's late tonight. Minus negative is plus a positive. So 3, -3 squared. This gives me something happened. Oh, good grief. Let's go back to AC. I apologize. So -8 minus a -5. See how easy it is to forget those little negatives? Gives me plus a positive. Changes this to a -3 squared, which changes this to a 9, which changes this to an 18. So I have AC is now the square root of 18. Going over here, I have -1 plus 4 gives me 3 squared. See, it helps because I knew what it was supposed to be. 9 plus 9, so BD equals the square root of 18. The diagonals are congruent. Okay, diagonals are congruent, so that means that it can be a rectangle or a square. So this is what it can be. I'm going to narrow it down, because if I figure out that it's just a rectangle, then it's not getting anywhere. So now I need to kind of go more specific. Is it a square? Well, how can I show that it's a square? So it's either a rectangle or a square. Well, I know a square is also a rhombus. So what makes a rhombus a rhombus? Well, diagonals have to be perpendicular. We could also just show that since we already know that it's a rectangle or square, we know that opposite sides have to be congruent in a rectangle, but all sides need to be congruent in a square. Again, I think I'm going to go with the diagonals. I'm going to prove that diagonals are perpendicular, so are diagonals perpendicular. So I have AC. Remember, perpendicular means that we're going to be using the slope formula. So AC is -4 minus is part of the formula of slope, -1 over -8 minus a -5 plus a positive, I get -3 over -3 gives me a +1. So the slope of BD, need it to be an inverse of this. So what's the inverse of 1? It's going to be a -1. So I have -4 minus a -1 over a -5 minus a -8 plus a positive, -3 over 3 gives me a -1. So these are reciprocals, opposite reciprocals. Therefore, the diagonals are perpendicular. So let's go back up here. So if diagonals are perpendicular, that would be a rhombus and a square. So up here, we've already shown that it is a rectangle. Down here, we showed that it's a rhombus. So it's a rectangle and a rhombus. Well, by definition, if it's both of those, then it is also a square. So if you were wondering the most specific, you would say that it is a square. If it was asking list all that apply, well, if it's a square, that means it's also a rectangle and a rhombus, which means it's also a parallelogram. Okay, again, there's example 2.